This
Now,
conference will now be recorded.
Yeah, hello, this is Dr. SADAT, who is taking a class on cardiac cycle and cardiac potential. Yeah, let me continue. Okay, now I will just note this down, guys. Everyone note this down. Okay, now I will equate 0.1 seconds as one systole and 0.1 second of diastole. Understood what I'm trying to do? I'll show you, do not worry. Okay, now atria, how many times did I say diastole is occurring? 7 times. 0.7 seconds. Okay, I'm referring to as 0.1. So diastole, 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 diastole. 1, 2, 3, 4, 5, 6, 7. And only one systole is occurring. One systole is occurring. Let's see in ventricles. Let's see in ventricles. 3 systoles are occurring. SSS. Okay, and diastole is occurring 5 times. So diastole, 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 diastole. Okay, just note this down. This table, this thing which I've written over here. It's for your ease to understand. Nobody will tell you this. Okay, look at it over here. We will be starting the cardiac cycle from here. What is this? This is atrial systole. We will be starting. I will be starting my explanation from here. Okay, remember that. Remember that. Then we will go all the way from up till here. Okay, remember this. Remember this. And if you notice, specifically, they are coinciding together diastole. If you can see, 4 seconds, 0.4 seconds of the cardiac cycle is actually occurring in diastole, meaning the whole heart is relaxing for 0.4 seconds. Okay, for 0.4 seconds. Understood? Yeah, remember this, meaning that only systolic is occurring only for in ventricles for 0.3 seconds and in atria 0.1 second. Okay, just remember this. Just remember this. Okay, just note this down. I will once I will explain in detail, you will understand. Now let's go to the most important part. Let's go to the most important part. Now you have understood the classification of cardiac cycle. You have understood the basic durations. Specific now in subdivisions also, I will show you what are all the durations. Okay, now let's go. Okay, atrial systole and atrial diastole, which is present, it does not have any subdivisions. Whereas ventricular systole has subdivisions and ventricular diastole has subdivisions. What are the subdivisions? Note this down now, and then when I will be explaining, you can correlate and understand the concept. Ventricular systole I'm talking about. What are the events happening in ventricular systole? First one thing is known as isovolumetric. What is this systole? Systole means contraction. So contraction. I will explain why is it called isovolumetric. Do not worry, just note these phases down. Then I have a phase known as rapid ejection phase, and I have reduced ejection phase. Actually, both these come under ejection period. Okay, ejection period. Okay, understood this? What is this? This is ventricular systole. Let's come to the ventricular diastole. Note this down. Noted, everyone? Let's go. Now, here we have 5 subdivisions. Here we had 3 subdivisions. Here we have in diastole, ventricular diastole, we have 5 subdivisions. Let me just name these divisions, and then once I will explain you with diagram, you will understand it completely. First stage is known as protodiastole. Next stage, or this, is known as isovolumetric. What is this? Diastole. Diastole means relaxation. Okay. Again, same. Rapid filling. There was rapid ejection because it is contraction. Now, the blood will eject from the ventricle. Here it is relaxing, diastole. That's why it is telling filling. Reduced filling or slow filling, we can call. The most important 5th phase known as rapid last rapid, whatever you may call it, filling. This occurs when atrial systole is occurring. Understood? This occurs when atrial systole is occurring. Just note these down. Mind my handwriting, please. Sorry, guys. It's on the device, right? So my handwriting is really bad. Yeah. So last rapid filling is occurring in when atrial systole is occurring. Okay. I'm starting from here now. I'm starting with the diagrams from here. Let's go in the diagrams. Understood this divisions? Atria, no subdivisions, only ventricles. Ventricular systole subdivisions are 3. What are the 3? Isovolumetric contraction, rapid ejection, reduced ejection. Same, these three things are there, except you have to write the opposite. This protodiastole is only present in diastole. Isovolumetric relaxation, similarly contraction. Rapid filling, rapid ejection. Reduced filling, reduced filling, reduced ejection. Rapid fill, last filling, last rapid filling, you can call it. Atrial systole is also occurring. Sorry, it's very rough, but I'm trying to explain. Okay, let's go. Now, is there any doubts up till here in the divisions? Is there any doubts? I'm going to start with the diagrammatic explanations. Arbaz, just tell me if there are any doubts.
No, they aren't any.
Okay, I will be proceeding now. Let's go. Okay. What did I say? I am going to start from atrial systole, right? What is happening in atrial systole? As you all know, the SA node stimulates, but along with the stimulation, you have superior vena cava blood coming and inferior vena blood coming. So now I will mark it as light blue. Okay, light blue. Okay, now look at the chambers. Look at the chambers. This is our right ventricle. This is our left ventricle. Now, when the blood increases over here, the pressure increases. Pressure increases. Agreed? Pressure increases. But I also told you today's important principle. What was the important principle? When the chamber contracts, what happens? Pressure increases. So more increase in pressure is happening. What will happen now? Tricuspid valve, this T-crust valve will push open. What will happen now? Blood will come into right ventricle, because this pressure increase the overwhelmed the right ventricle's pressure. Understood this? What is happening in atrial systole? Nothing, just blood is coming into the right atrium. SA node is stimulating, contraction is of atria is happening. That's why we are calling it atrial systole. Blood is entering the right ventricles. Okay, but zyada kuch nahi hai, nothing much is there in this space. Okay, but I just want you to note down. Atrial systole helps in very little amount of entering of blood. Very little amount of blood. Already, it will be, this chamber will be filled with 3/4 of the blood. Only very little amount of blood it's helping in entering. Okay, why I will explain. Just note down the atrial systole. Next. Now we know that atrial diastole will occur, but this will happen afterwards. We will now jump into our ventricles. What will happen in ventricles? Now I'm going to discuss about ventricles, because I told you once we jump into the atrial systole, we'll jump into the ventricles because blood is flowing into the ventricles. Now the ventricles I will be explaining. Okay, now in ventricles I will be explaining about the systole phase. Okay, now listen carefully. Now this is our right ventricle and this is our left ventricle. Now what did I say? Blood is accumulated. Now again my principle comes in. Again, not my principle, the nature's principle. What happens? The right ventricle pressure increases now. Okay, so as soon as the right ventricle pressure increases, what will happen? When we compare it with right atrium, it overwhelms, right? So what is there in between? Tricuspid valve is there. What will this do? It will push the tricuspid valve. What will happen now? Tricuspid valve will close. What do I mean by close? What did I say? Again, one more principle I mentioned. What will happen? When it will close, a hard sound is produced. This is our first hard sound. Understood? What is happening? Right ventricle is filling up. Then it's overwhelming the right atrium. So pressure is increasing. Tricuspid valve is closing. Okay. Now listen to me carefully. We also know that it is connected with the pulmonary artery. Pulmonary artery has what? It has pulmonary valve. Now I already explained you that. Again, I will explain. Some people were having doubts. I already explained you that right atrium has 5 mm pressure. Right ventricle has 20 mm. But pulmonary artery has how much? 25 mm pressure. Right. So what is happening now? Right ventricle's pressure is lesser when compared to pulmonary artery. So blood will not flow into the pulmonary artery, but we want the blood to pump into the pulmonary artery. So what do we want? What can we do? We can increase this pressure. We can increase this pressure, na? That's because we want this blood to, right ventricle's blood to enter into the pulmonary artery. So what is happening now? What is happening in this diagram? Yeah. So this is a chamber which is closed. This valve is also closed, and here also our tricuspid valve is closed. Now I will pause for a minute and I will tell this one stage of the cardiac event. I will name this one of the events of cardiac event. What will I name this? Isovolumetric. Remember, I was in ventricles in systole. So in systole, remember I gave you the classification. I'm writing down here. Isovolumetric contraction. Why am I calling it isovolumetric contraction? Because now it is a closed chamber, na? Udhar se from right atrium we have seen that tricuspid valve has closed, and from pulmonary artery we are seeing that pulmonary valve is closed. So what is happening? Left ventricle, right ventricle is like a closed chamber, na? So what about the volume of the blood? What about the volume of the blood? It remains same, but what is happening? The Purkinje system is stimulating it. So what is happening? Tell me. Contraction, right? So pressure is increasing, right? So what am I calling this? Isovolumetric. Volume is remaining same in this closed chamber, but contraction is also occurring. That's why isovolumetric contraction. Understood? Understood? Please put in the chat box if you have any doubt. Understand the first heart sound, understand the isovolumetric contraction, why it is called, how it is occurring, why it is a closed chamber. Understood? Any doubts, put in the chat box. I'll be moving to the next phase, next stage or event.
No doubts. No, as of now, no doubts.
Okay. Cool. If there is any doubt, just let me know. Next stage, everyone. Next stage. Remember, I'm still in ventricles in systole. Okay, let's go. Now, what did I tell? Simple. Right ventricle's pressure was overwhelming the pulmonary artery now. Pulmonary artery. Why? Because Purkinje system activated the right ventricles. So pressure extreme is happening over here. Plus, the chamber is full, completely filled. What is happening? This pulmonary valve present over here, what is happening? The pressure in this is becoming less compared to right ventricles. Since this was around 25, this will become 30 mmHg. Push. What will happen? Opening of the pulmonary valve will happen. Blood enters into the pulmonary artery. Now, what is this phase called? Still in ventricles, still in systole, everyone. What is this called? Rapid ejection phase, everyone. Rapid ejection phase. Why? Because the right ventricle has overwhelmed the pulmonary artery. So the blood has flown into the pulmonary artery. Initially there is most of the blood is ejected from the right ventricle. That's why we are calling rapid ejection. But there is also one phase called as, nothing much to know about this phase, reduced or slow ejection. Almost the whole ventricle has emptied. Thoda sa little blood is left. That blood will be also ejected out. Matlab, I just want to tell you that now there will be a slow ejection. Initially, Purkinje system will act enormously, okay, and slowly the power of that ejection will be decreased. So reduced ejection, okay, reduced ejection. So we are calling it as, we're giving it a name, reduced ejection. So what all are coming in systole? Tell me, everyone, what all are coming in systole? First, isovolumetric contraction, ventricle systole. Next, tell me, here we heard the first heart sound also. Why? I explained completely. If you have any doubts, ask. Okay. Next phase in ventricular systole, rapid ejection. Next phase after that, reduced ejection. Understood? Just a note point, even though there is enormous amount of ejection of blood, still a little amount of blood remains in the right ventricle. What name should we give this? It's after systole. So end systolic volume. How much amount it should be? 60 ml it will be. Okay. If you want to remember this, you can, but it's not so essential. But I just want you to know that there will be a little amount of blood still left in the right ventricle. Now let's jump into our diastole, ventricular diastole with diagrammatic representation. Till now, if there are any doubts in the ventricular systole about anything, please put it in the chat box. I will be starting the diastole.
Someone wants you to repeat reduced ejection.
Yeah, there's nothing much to know, ma. Reduced ejection is not nothing so serious. See, rapid ejection, what did I tell? The pressure is fully increased in this. Purkinje system is activated. Right ventricle is filled completely with blood. It will push against the pulmonary artery, and most of the blood will eject out fastly. Okay, most of the blood will eject out very fastly. So that's why I giving it a name as rapid ejection. Okay, then after that, suddenly the heart is not able to pump that strongly, but it is still ejecting the blood out into the pulmonary artery. That's why we are giving this also a name called as reduced ejection. Means rapid ejection occurs very fastly. I will give you the time duration, do not worry. Reduced ejection occurs slowly. That's why we are able to notice this phase. That's why we are giving it a name. Nothing much serious. Okay. Okay. I think that clears it. Let's jump to our
Someone wants
ventricular
you to
diastole.
address why it is called isovolumetric contraction.
Yeah, I actually told it. Again, I will repeat. No problem. Okay. So let's see. I'll just fastly explain. So this is our heart now. So I already told you atrial systole ho jata and the tricuspid valve closes. Tricuspid valve close ho gaya. Now this is our. I will not speak in Urdu. Sorry. This is our right ventricle, and this is our pulmonary artery. This is our pulmonary valve. Okay. Now what I'm trying to tell is blood entered into the right ventricle, and first heart sound was produced by closure of this tricuspid valve. First heart sound was produced by closure of the tricuspid valve. Okay, you understood this? How the pressure causes the closure of the tricuspid valve? Understood. Okay. Now this pulmonary valve is also closed. Okay. Now what should I tell? This whole blood is just accumulating here, na? What is happening here? How is it acting as? It is acting as a closed chamber. It is acting, right ventricle is basically acting as a closed chamber. Now, what I'm trying to tell is the amount of blood will remain same now since it is a closed chamber. From atria, no blood is entering, and into pulmonary artery, no blood is going. So it is acting as a closed chamber. So what I'm trying to tell is, what do you mean by closed chamber? Blood remains same. The amount of blood, the volume of blood remains same. So when I'm telling isovolumetric contraction, when Purkinje system activates this, volume of blood is remaining same. That's why isovolume, but contraction is occurring. That's why we are naming this as that. I hope that clears. If not, again, you can put it in the chat box. No, sir, I did not understand.
You have completed, I think 30 minutes. It's 7:33 now. Someone is asking something.
Okay.
Wait. How blood enter into pulmonary artery from right ventricle, because pressure is less in ventricle than pulmonary artery? Then how?
Yeah, I already explained it, right? So
Yeah.
now, right ventricle and pulmonary artery are present, right? Blood entered from the atria. Okay, understood this? Blood entered from atria. Tricuspid closed. Now the amount of blood is this much, for example. Okay, now it is also connected with pulmonary artery. But what did I tell? Purkinje system comes in action. Purkinje system comes in action. What is this Purkinje system? It is our conduction system. What it will do? It will depolarize. It will try to contract the muscle. It will send signals for the contraction of the ventricle. If that Purkinje does not work, how will the muscle contract and how will the blood pump from the right ventricle? It has to activate now. It has to pump this. It has to contract this right ventricle. Okay, so since this right ventricle is contracting, I already told you in the starting of the class, when any chamber sorry, yeah, I already explained in the class that when any chamber contracts, what will happen? Pressure will increase. So as when I told that pressure will increase, what is happening when we compare it with pulmonary artery? This pressure is increasing. Initially it was not increasing. This was more. Initially this was more, but now since Purkinje system activated, volume also is increasing. This it will push against the pulmonary valve. Understood? That's why it's able to push now. Understood? I think that explains it. I think. I hope.
Yeah, I think
Okay.
you can continue. There are many doubts coming, but I think you can take them at the end of the session. Okay, is that okay?
Yeah, I think
Or
so.
if you want to take
If
it now, you can. Because
there are
this is
many
a
doubts,
vast
then
topic.
yeah, I know that. But if there are
No, they
many
are
doubts, I think they're
asking
not
not
able to answer.
related to this. They are asking some
Achha.
other doubts.
Okay. We will address that afterwards.
And I'll like to add a bit over there. Someone asked about isovolumetric contraction, right? So isovolumetric contraction, why we are calling isovolumetric? Not only because of the volume of the blood is not changing, it is because the volume of the chamber which is not changing. So first the tone of the muscle will increase. After that the muscle will shorten and contract. So first the muscle is not shortening, right? So the chamber volume is not changed over there. Only the tone of the muscle is increasing. So the phase where only the tone of the muscle is increasing, there is no change in the volume of the chamber. So that is known as isovolumetric contraction. I hope that addresses that question. Wait a second. Any more doubts over here? Someone is asking what is the significance of end systolic volume of blood. If you want to address, you can. Does tricuspid valve open once the pulmonary valve is open, or is it closed? And up to which event of cardiac cycle?
Just repeat the question.
Does tricuspid valve open once the pulmonary valve is open, or is it closed? And up
No,
to
no,
which
no.
event of cardiac cycle? Yeah.
Yeah. So tricuspid valve, when atrial systole occurs, it opens. Okay. And when it enters into the this is atria. Now when we see in the ventricles, when the ventricular isovolumetric ventricular contraction, it enters into this phase, I told you it will push the tricuspid valve and the tricuspid valve will close. But now it's acting as a closed chamber. So pulmonary valve is also closed now, tricuspid valve is also closed. In the next phase, in the rapid ejection phase, pulmonary valve opens. Understood? 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 Isovolumetric contraction, only one thing is happening. The tricuspid valve is closing and the first heart sound is being heard. There is no opening of valves. But when we enter into the rapid ejection phase, the isovolumetric contraction is overwhelming. That is, the right ventricle pressure is overwhelming the pulmonary artery, and then pulmonary valve is opening. There should be no confusion in this. Okay. Tricuspid valve and bicuspid valve, these are atrioventricular valves. They open and close together. And pulmonary valve and aortic valve, they open and close together. These are known as semilunar valves. Do not confuse this with this. Okay. These are two separate entities. These guys are bros. These guys are not bro. These guys are bros, but don't mix these bros. Okay. Try to understand. Okay. Let's go. Now I'm in the diastole. I'm in the diastole. Okay. I will address all your doubts. Do not worry. We can increase the time for the session for doubts, but we cannot increase the time for teaching the subject. No? So I'll just start continuing. Okay. Now this is our pulmonary artery. This is our aorta. Just pictorial representation. This is our left ventricle. This is our right ventricle. Now, from which phase did we enter? From which phase did we finish from? Ventricular systole mein we were in reduced ejection. Now, ejection. Right. Now, what do I mean by this ejection systole? The muscle is completely, the chamber is completely contracted. Now, it's completely contracted. But now what will happen? We are entering into the ventricle diastole phase now. Diastole phase. What will happen now? What will happen now? Slowly it will relax. Not completely, just initiation of relaxation. That is the pressure just since the blood was completely ejected out. Now what will happen is just initiation of the decrease in pressure is known as protodiastole. But the only important event occurring in this is we'll hear the second heart sound. Why and how are we able to hear the second heart sound? Why are we able to hear the second heart sound? See, here we have, I will just zoom in. Here we have pulmonary valve. Here we have the aortic valve. Now, this is our pulmonary valve. This is our aortic valve. What did I tell you? How does closure occur? When the pressure pushes it. Now I want you to compare, since the blood is ejected from the right ventricle and also from the left ventricle into the aorta and pulmonary artery respectively. Okay. Now what will happen is, these are, aorta especially is an elastic artery. Okay, it tenses very much. Tension is very much present in these two arteries. Not so much in the pulmonary artery, but aorta very much. So pressure increases in this. Okay, because blood hai na usme. Just now they ejected all the blood they had, all the energy they had, all the pressure they had into this. Now what will happen again? Similar concept. Since pressure is overwhelming here, this valve present here and this valve present here, nothing but aortic valve, nothing but pulmonary valve. what will happen? It will just becoming too clumsy, but try to understand. It will push the valve. What will happen? Closure of valve will occur. Closure of pulmonary and aortic valve will occur, producing a second heart sound, which is a normal physiological sound. Okay, till here did you understand what is happening protodiastole? Nothing much importance of protodiastole except that there is a decrease in pressure that is resulting in closure of the pulmonary and aortic valves, which are nothing but semilunar valves. Understood this? Importance of protodiastole. I will completely explain in a summarized way in paper presentation, but just understand the concept, how and why it is occurring. Now, what did I tell you now? What did I tell you now? Just a slight pressure decrease हुआ था ना? Now what will happen is this contracted ventricles, now they will relax. Aram se they will relax. There is no stimulation, there is nothing. They will relax now. What name should I give to this phase? Simple. We are in ventricles diastole. So I already explained the protodiastole. Now we are in the second phase. We'll give it a name, isovolumetric relaxation. Now again you will ask me, why is it called isovolumetric? Again I will explain. Key tricuspid valve is also closed and bicuspid valve is also closed. And suddenly just now in the before stage protodiastole, pulmonary valves got closed and aortic valve also got closed. Again it's becoming a closed chamber. Again the volume of blood remains same. Now that amount of jitna bhi amount of blood is remaining, that is getting relaxed, though, so the volume is remaining same. So since it is relaxing and it is a diastole phase and the volume is remaining same, I'm calling it as isovolumetric relaxation. Okay, I think this will be understood by you. If there are any doubts, put it in the chat box. We'll see. Okay, next phase. Again, similar things, similar phases, similar names. Now what is this phase called? This will extend like this. Now complete relax ho gaya. Okay, now what will happen is something is going to open now. Yeah, sorry, I forgot to tell you here only. Yeah, because here protodiastole there was no opening of nothing, there was no opening of valves. But here at the end of this phase, just at the end of this phase, what will happen? Tell me what will happen. Right atrium, right ventricle, left atrium, left ventricle. There are valves present in between. This is tricuspid valve, this is bicuspid valve. What I'm telling, pressure is decreasing. What will happen when pressure will decrease? Tell me. Blood from here will push. What will happen? Valves will open na, because pressure is decreasing here. Relax ho gaya na bhai. Right ventricle and left ventricle have relaxed. So what will happen? These valves will open. So at the end of isovolumetric relaxation, what will happen? AV valves, that is tricuspid and bicuspid valve will open. I think there might be some confusion over here. Did you guys understand? Arbaz? Hello?
No doubts.
You understood,
Arey,
right?
not
Okay.
Yeah.
they didn't understand.
Okay.
Yes.
Okay.
अच्छा no मतलब okay.
Now AV valves खुल गए. AV valves खुले तो क्या होता? What will happen when AV valves open? In isovolumetric relaxation, this valve is open. This valve is open. This is the right atrium. This is the left atrium. This is the right ventricle. This is the left ventricle. Blood will come inside. So what will happen just when this is our water pipe? I'm blocking something with it. Okay. What will happen when I will just remove it initially? With full pressure it will come outside, right? So what are we giving this name? What are we giving this stage a name? Rapid filling stage. Rapid filling stage. Remember, the most important point in this stage is 70% of blood enters in this phase into the ventricles. Okay, 70% of blood enters into the ventricles in this phase only. Next, let's proceed. There we go. Now what will happen again? slow blood will come. Initially pipe I had removed the obstruction, and then suddenly with full force it came. Now what will happen gradually? Slowly it will come. Now similarly to that, now there is again blood coming, still blood is coming, entering into the right and left ventricles, but slowly. So we're giving the name as reduced filling. Okay, reduced filling or slow filling, you can call it. Slow filling we can call it. Understood till here? Understood here? What all we've covered in ventricular diastole? We covered from protodiastole, then we went to isovolumetric relaxation, then we went to rapid filling, then we went to reduced filling. Last stage is left. Last stage is left. What is this stage called? Last rapid filling. Again, you may ask me, already you told here there is rapid filling. Why is there again rapid filling occurring here? Huh? Why is there occurring here? Now there will come action of our atria. Atrial systole will occur now in this phase. Understood? What will happen now? Yeah. So I mentioned here this 70%. Now, what will then? How much percentage will this cause? Take it as 20%. 20% of blood is only coming from this phase. It's only responsible for this phase. When we come to the last rapid filling of atrial systole, only 5 to 10% of blood. As exactly I have told you in the starting of the atrial systole, when I told you that only 5 to 10% of it is responsible for the blood filling of the ventricles. This is how the mechanism occurs. Most important mechanism is rapid filling. 70% is coming from there. Then reduced filling, then atrial systole. Okay, now what all we have completed? I will just summarize in short words. First, we started with atrial systole. Okay, I have not covered atrial diastole. I will tell you, it's very simple. We started with atrial systole. I told you. Then we entered completely into the ventricles. We became bros with the ventricles. Now, in ventricles, what did we do? We started with the systole. Systole, what did happen first? Isovolumetric contraction, because it's systole. Then what did happen? What happened? Rapid ejection happened. Then what happened? Reduced ejection happened. Understood this? How the blood is entering into the pulmonary artery. Okay. Then we discussed about the diastole in ventricles only. We discussed about the initial known as protodiastole. What is the only important thing happening here? Second heart sound. And here in this IVC, first heart sound, right? So that's the only significance. Then what did we discuss? Isovolumetric relaxation. Then what did we discuss? Rapid filling. Then reduced filling. And reduced filling. And lastly but not the least, our last rapid filling. This is the name of the stage. Do not write it as atrial systole. Write it as last rapid filling occurring due to atrial systole. Okay, this is the main name. Last rapid filling. Okay, so now this is our cardiac cycle. Well, nothing happens in atrial diastole. This is the only time atria will be in systole. Rest all of this events occurring in ventricles, what is happening in atria is remaining in diastole, as we have seen in our small box which we had made over here. See over here. Now try to correlate. We started from here. What happened? Atrial systole happened. Okay, but here we can see that ventricle is filling. Now last part of the filling, last rapid filling is this phase. Then it will enter into systole, but this will enter into diastole. See, we can correlate with this. So put this box whenever you want to correlate the events happening. Okay, understood. And this specific area is heart is completely relaxing. Atria also are in diastole, ventricles are also diastole. But here we have this systolic stages, and this is the one systole stage. Okay, now I've tried to explain what are all the events occurring. If there are any doubts, Arbas, just try to address. I will start with the atrial. I will start with the pressure curves. Then I will end with the cardiac potential. Then paper presentation also I will tell after cardiac cycle. Just see whether there are any doubts.
No doubts.
Understood. Wow.
SADAT, would you like to mention about end diastole planning? Are you going to mention?
No, I am not able to hear you. Hello?
Are you going to mention the end diastolic volume?
Oh, end diastolic volume. Yeah, I forgot to tell you. It's simple. Just you have to remember. If you want to mention, you can mention. It's not so essential. I will just mention it over here. Here. After this phase, what will happen? What will be the end diastolic? What do you mean by end diastolic volume? Complete relax ho ja raha ventricle. When the ventricle completely relaxes, that is known as what? How much volume of blood remains in the ventricles? That name we are giving as end diastolic volume. Okay, understood? How much value it will be? 130 to 150 ml. Okay. How much end systolic volume was there? Only 60 ml. Okay, only 60 ml. Nothing much. Okay. Understood?
What is its significance in the end diastolic volume? What is its significance?
I think it will signify the. There is one more concept, ma. It's known as ejection fraction. It will determine the pumping ability of the heart. Understood? See,
The cardiac
if
output.
130 to 1, yeah,
is
cardiac output, exactly. Ejection
determined.
fraction or cardiac output, yeah, you can tell. Stroke volume and all are there. Okay, we'll not go deep into that. But see, if it is 130 to 150 ml, we know this value. We measure this value. And when the heart contracts, if only 40 to 50 ml is being ejected, and still there is 100 ml left, what is this? This is seen in MI or some cardiomyopathies. Heart is not able to pump. Only this much amount of blood is getting ejected, and systolic volume is becoming only 100. So it's too much, na? It has to at least be 60 ml or less than that. Okay, that's all. That's the significance.
Yeah. What is the other name, sir, for this end diastolic volume?
Other name? I don't know.
Preload. It's also called as preload because the factors which determine the cardiac output, this is very important. The preload, how much blood is coming. So just wanted to highlight, it would be easier for the students to grasp at this time. What do you mean by EDV? Yeah. Sorry to interrupt. And you can go ahead.
No problem. Let's continue to our pressure curves. So I think you guys have understood the concept. Do not worry. I think you guys are freaking out. I have made this how to present on paper like this over here. So see, I have kept everything. I will send you the screenshot also. Do not worry. Okay. So now let me explain you the concept. Okay. Let's go to our. Someone is unmute. कौन है अरबाज है? Kindly unmute Arvaz. Mute, sorry.
Someone.
Okay. No problem.
Now, please mute it.
Atria.
Father, are asking you to read the DD and SS sequence. Many of them are asking you to just repeat the DD and SS sequence which you wrote in that box.
Oh, okay. Simple. Okay. No worries. See, I told you guys, right? Atria mein, I will take everything as 0.1 seconds. I told na. Systole, how much time I give? 0.1 seconds I give in atria. And here I give 0.7 for diastole. 0.1 is 1 only. So diastole ko main 7 times likh. Yeah, 7 times. Someone is unmuted. I think I'm having a disturbance. Only one systole. Ho gaya? Atria understood? Nothing much to worry. And then we have ventricles. Ventricles, what I'm doing here is, listen, ventricles, what did I tell? 0.3 seconds is for systole and 0.5 seconds is for diastole. Both have to equal 0.8 seconds. Totally 0.8 seconds mein dono activities ho ja rahi together. Here we have systole 3 times, which I have written here. And then I'm putting the diastole 5 times. Understood? Copy it down. If you have any doubt, you can personally DM me after this session. Okay, let's go. I have to start with the pressure curves, and I'm having only 1 hour. I have to cover cardiac potential also. Inshallah.
Grishma and Nambuli, please mute your mics, please. I request you to mute your mics. Grishma and Nambuli, Kalyani, someone is there. Please mute your mic.
Yeah. Okay. Let me start the session.
How much time more will you take, Sadat?
I will be taking more 45 minutes, Arvas. Do you have to add anything?
Okay. No, I don't want to add, but for the attendees, I was asking, can you end it by 8:30?
Yeah, but I have
Try
to
to end it
hurry
by
up.
8:30. Okay, take your time.
No, actually,
8:40 tak kar do.
yeah. I had put in the chat box, right? It may take 1 hour, 1.5 hours to 2 hours. So I think they are prepared. I think.
Okay, sure. Take your time.
They have
Okay.
to be prepared because at the edge. They have to be
Okay.
prepared because they are at the edge of writing their final exams,
Yeah,
right? So
exactly,
please be mentally
exactly.
prepared, everyone.
Yeah. Okay. Okay. Let's start. Let's start. Okay. First, we will start from atrial systole. Now, in our heart, initially we will start with the atrial systole. Atrial systole हुआ तो pressure क्या होता? What will happen to the pressure, guys, when atrial systole occurs? Increases, right? So initially from suppose I'll put some value 0 or something. Initially in the atrial systole over here, it will produce a wave like this. This is a pressure graph. Okay. When how will I measure that? There are various phlebograms, catheterization. We'll not go into that. Just remember there are pressure curves. We will measure it. So this is one wave which is produced during atrial systole. Why is it produced during atrial systole? I've already told you that when cardiac chamber contracts, pressure increases. We will name this chamber as A. This curve as A curve. Understood now? Understood. Now, suddenly what is happening? Suddenly there is a little bit descent over here. We call it as descent. Why is this descent occurring? Just after contraction of the atria completely into the ventricles. I will only draw the right hand part of the heart. See, this atria is completely contracted now, no? So what will happen? Complete blood is over here, but slowly it will relax a bit just after the contraction. So that will produce this thing known as X. No need to go into the details, guys. No need to go into the details of pressure curves. But the only thing you have to know is you have to mention this or draw this in the exam. Okay, you should draw this in the exam and just write the stages where it is appearing. That's all. No need to go into detail, but I will explain to you how it is occurring. Then again, one more phase occurs. This is known as C. I'll tell you how the C is occurring. It is occurring in isovolumetric contraction. I'll rub this out. See, listen carefully. I'm talking about atrial pressure curve. Okay, atrial pressure curve. Now, see, this is our right ventricle. Isovolumetric contraction. What will happen in isovolumetric contraction? This tricuspid valve is also closed. This pulmonary valve is also closed, but it is contracting. This ventricle is contracting. What will happen? It seems, listen up closely, it will slightly push this. It seems it will not open this tricuspid valve, but due to the contraction of the closed chamber, slightly push karta. So this pushing into this is the right atrium. So this is the valve. Little pushing of this valve into the right atrium causes a little increase in the pressure. Again, this will also be noted down in our pressure curve like this. So that's why we are naming this as C. So now let's revise. A is occurring when atria is contracting. Obviously, we know that. It's easy. Just after contracting, what will happen? It will relax a bit. Atria will relax a bit. Next after that, what will happen? Ventricles are contracting, but the valve is pushing a bit into the atria. That's why we are getting this will be lesser than the A wave. It will just be like this. Okay. A little slight pressure is also noted when tricuspid valve is pushed into the right atria. Understood this? Now, what did I tell? Rest of the time it will be in diastole, na? Atria will be in diastole. Most of the cycle. Again, we'll give this as a name. X dash descent. Okay. Again, this is seen in which phase? When the ventricles are ejecting. Ejection period of ventricles. This X descent will occur. See, all you have to do is even if you are not able to understand, what you can do is just see which wave is seen in which phase and just draw it in the exam. You will learn about this more in the future, but for now just understand which phase which curve is coming. Just that's all is required at your stage. Okay. But you have to be perfect in cardiac cycle. If that is perfect, you shouldn't worry. Ejection period mein atria will be in diastole. Ejection of ventricles is happening, but atria is in diastole. I showed you, most of the time it is in diastole. 7 times diastole, 1 time only systole is there. So most of the time it will be in diastole. So this whole phase This is time. This is pressure. Okay, so this is descent occurring in ejection of ventricles period. Okay, don't worry. Now again on positive curve is coming. Again on positive curve is coming. Why is this happening? Why is it happening? It's happening in isovolumetric relaxation phase. Why is it occurring? See, I'll show you. Sorry. Right. See, when isovolumetric contraction happens, isovolumetric relaxation, relaxation happens. What is happening? The pressure is decreasing in the ventricles, but the blood is ejected already, and the blood is entering into the right atrium. So the entry of the blood into the right atrium is causing is V wave. Understood? Understood? It is still in diastole, but since the blood is entering, it is causing the V wave to happen. Understood? Guys, are you understanding or not? Arbaz, just let me know if they are getting confused in these pressure curves. Arbaz?
Someone is saying yes, someone is saying no.
You are getting
Someone is saying it's
mix of
clear.
answers.
Someone is saying,
Huh?
please explain the graph after IVC.
IVC. Okay.
But
Okay.
you got
No,
multiple
that
no's,
is.
so I think you should repeat.
Okay. Okay. No problem. I think they're getting confused. Okay.
Just
This
space and the curve, so it would be clear.
Yeah, don't worry. I think it's better to just write down. I will write it down when it is occurring, and then I will explain on the graph. So a wave occurs when there is atrial systole. Okay, understood till here? It is a positive because pressure is increased. Then we have a X descent occurring when just after atrial systole it relaxes a bit. Okay, relaxation of atria. So it is a descent. Pressure decreases. Relaxation means pressure decreases. Contraction or systole means pressure increases. You know this. Again, see, positive wave is occurring. Why is this positive wave occurring? This is positive, this is positive, this is negative. Why is the C wave occurring? Because tricuspid valve is putting pressure on our beloved right atrium. How is it producing? Because ventricles are isovolumetric contraction. This isovolumetric contraction phase in the ventricles is pushing a little bit of tricuspid valve into the right atrium. So that's why it is showing an increase in the pressure. So that's why positive. Again, this is also positive curve, C wave. It will not be more than A wave, but it will be a little positive wave. I think they're getting confused in the C wave only. Do not worry. Tricuspid valve is entering a little bit or pushing a little bit into the right atrium. I'm telling. That's why the right atrial pressure is increasing a little bit. It's showing a little bit in the pressure graph. That's all. Nothing to worry. Nothing serious about it. Okay. Or just remember that tricuspid valve is responsible for this C wave. Simple as that. Tricuspid valve is pushing into the right atrium. That's why C wave is seen. Okay. Just listen to that. Just understand that. Next, not last, we have again X dash descent. Whenever I'm telling descent, it is a negative wave. Negative wave means decrease in pressure. Why decrease in pressure? Because atria remains in diastole. These events are occurring at special locations like atrial systole or when there is tricuspid valve involvement. But rest of the time, though, it's relaxing only, na? Relaxation. So descent. Now, V wave. Why are you getting confused in V wave? It's nothing serious. Now, V wave occurs when this guy cannot sit relaxed without worrying about anything in diastole, right? It has to do work. Blood comes again from venous system. After ventricles contract already into the systemic circulation, it's still in diastole. But blood is coming into the right atrium now. It has to come. So what will happen now? Pressure will increase because volume is increasing. Understood? The blood will come and put pressure on the right atrium. That's why a positive descent of V wave is seen. Understood now? Understood? Okay. I think I'm trying my level best, guys. I have to cover more topics also. Now, ventricular pressure curve also is there. Aortic pressure curve is also there. Okay. And then next we have again a Y wave. Again a descent. Y wave. Why is this Y wave occurring? Here we have opening of AV valves. Simple, nothing serious about this. What do you mean by opening of AV valves? This is right atrium, this is right ventricles. AV valves, they were closed, but blood was filling. That produced V wave. But now what is happening? These valves are opening. These valves are opening. So blood will enter into right ventricles. What will happen when blood enters into right ventricles? Here volume decreases of blood. So pressure decreases now. Then just after this pressure decreases, it will SA node will send a signal. Then again A wave will come. Then again C wave will come. X descent will come. Understood? Understood? Then now I will summarize again into the graph. What is the positive? I think I will do it like this. Right. So A wave I am told atrial systole. X descent I told relaxation just after atrial systole. C wave I told because of the tricuspid valve pushing into the atria. X descent I told again in diastole. V wave I told because blood is entering into the right atrium but AV valves are closed. So blood will put pressure on the right atrium. And again when V wave comes, Y wave comes, it is because of the descent, opening of AV valves, that is the volume is decreasing into the right atrium. It is entering into the right ventricles, no volume of blood. So descent will occur, meaning pressure will decrease. Now I will show you. A wave, relaxation of X descent, a little bit of C wave, then relaxation for most of the time, that is X dash descent. Then we have V wave. Then again we have Y wave. Now tell me, A is for atrial systole, X is for isovolumetric, X is for relaxation just after atrial systole. C is for, I will write it down like this, atrial systole. C is for isovolumetric contraction when tricuspid valve pushes into the right atrium. X again is for the rapid ejection phases and all, reduced ejection phases all. During ventricles when they eject and all, atria is in diastole, right? We know this. V wave is occurring when blood enters into the right atrium, but AV valves are closed. Y wave, why it is occurring? AV valves open, blood volume decreases, pressure decreases. Yeah, I tried my level best to explain. I think still people have doubts about this. Do not worry, guys. Do not worry. It is not of so much focus, but just remember A, C, X descent, V wave, Y wave will be there. At least if you remember the waves which are positive, which are negative, that will be more than enough. Let me jump into the ventricular pressure curves. So I will just go into the theory.
SADAT, please start the next topic. I think this is sufficient for this topic because this is getting prolonged. They can build up. You have made the concept very, very clear. I think they can build up now. Cardiac potential will be better.
Yeah, I will cardiac potential I will only be taking in 20 minutes. It will be easily finished. I will just explain the ventricular pressure curves and aortic pressure curves and it will be over. Just look at these graphs and no need to, I will send you the screenshots of this. Do not worry. Look at over here. This, oh sorry. What is this? Atrial systole. What is happening in atrial systole? This positive curve is there. Whenever this is the positive curve, whenever down is there, negative curve means pressure decreasing. These are pressure curves. So remember, atrial systole mein, why is it producing a positive wave? Because atria is contracting, blood is entering into the right ventricle, pressure slightly increases, not much, because it's not responsible for so much blood entering or very little blood is in it. AB ho gaya. Now IVC, what is IVC? Isovolumetric contraction. What is happening isovolumetric contraction? It is contracting like hell, na? Just starting to contract like hell. So it is like a closed chamber. So positive. Then what is happening in ejection phase? Completely bindas, it is ejecting the blood. Completely it is contracting. So more pressure. You can correlate as contraction is directly proportional to the pressure. Jitna zyada contract hota, that much increase in pressure will happen. Then come over here. This P, what do I mean by P? It is protodiastole, just initiation of relaxation. So that's why protodiastole, little relaxation, the downward curve. Then again you have isovolumetric relaxation, more decrease in pressure, rapid filling, reduced filling, more decrease in pressure. Finally you have what is this? You have a cysto. I think this is last rapid filling stage. Last rapid filling stage. where there's complete decrease in pressure. Nothing to worry. Again, there will be atrial systole. Again, there will be positive curves. Understood the ventricular pressure curve? Nothing much to learn. You can correlate very easily. I will send you the pictures. Lastly, aortic pressure curve. I already told you aorta has the highest pressure. Aorta has the highest amount of pressure present in it. So already it is present in the highest amount. Some variation will occur in aorta. Like for example, when pressure hits it, when left ventricle contracts and overwhelms it, blood enters into this now. That's why it will produce a positive curve. Seen in ejection phase. See, I wrote ejection phase, so it's correlated with that only. Okay, then we have a little bit of descent, which is due to ejection completely from outside from the aorta, and then little bit it will relax. That's why little bit descent is there. Then again it is in the high pressure zone only, but it will be slightly relaxed because blood is not pumping that much into the aorta. I think this is other detail. You shouldn't go into the pressure curves. Now just see the paper presentation. I will explain. Nothing much is there. First page. Look it over here. What you will write about cardiac cycle? You will write about the definition. Then in events, what you will write? You will write atrial events are there, ventricular events are there. Then again, what you will write? You will write side heading has divisions and durations. In divisions, what you will write? Atrial events, ventricular events. In atrial and ventricular events, again you will divide into systole and diastole. Ventricular events again systole, diastole. Time in duration you have to write. You have to write 0.1, 0.7, 0.3, 0.5. You wrote this. Now just write the subdivisions. Write the subdivisions. Ventricular means subdivisions. Ventricular systole is consisting of isovolumetric. I did not write that. Contraction. And ejection period. Again, you have two: rapid ejection, reduced ejection. Again, ventricular diastole is divided into 5 phases. Understood this first page? This is how you have to write in the exam. Next, you have to put this tabular form. You have to put this tabular form. They will get very impressed. 0.8 seconds, 0.8 second, atrial systole, diastole, ventricular systole, diastole. If you do not want to write this section of the table, it's okay. It's okay. It's not necessary to memorize each and every phase's time duration, but just mention the subdivisions. Mention the primary actions. What is happening? I will not go into the details of primary actions because I've explained clearly. Okay. If you have any doubts, you can ask me in the DM. Atrial systole. Now you will write about the atria. What is happening in atria? Systole, diastole, intra-arterial pressure curve. Bus. This is how you should write the exam. This is how you should prepare. Whenever before the exam, you should not go inside the details. Just headings, like this tabular form, headings, notes. One whole page you should cover with the cardiac cycle. One whole page. Like this I do now. This is the third page of the test. Atrial systole, isovolumetric contraction as a closed chamber. You can see the diagram is perfect. Then you have ejection, rapid, reduced. See, then again you are in the protodiastole. These small boxes I put now. You have to mention which valve is opening or which valve is closing. That's all you have to do. Then you have this isovolumetric relaxation. See, I put how it is relaxing with the arrows. Then I put over here rapid and slow ejection filling phase. And then again reveal into the atrial systole. This is how you should do in the exam. Then you have to explain the ventricular events. Systole you will explain IVC, first start sound, rapid, slow, and systolic volume kita. Diastole you will explain the 5 phases. Inside this also you should write. You should not just mention. Then lastly, pressure curves. Atria, ventricle, atria above you mentioned, ventricular and aortic you will mention here. Over. The answer is over. Cardiac potential. Come over here. Cardiac potential. We're going to start now. If you guys want 2 minutes break, I will take 2 minutes break.
Yes, meanwhile, if you people have any doubts, you can ask for 1 to 2 minutes. Let him take some rest.
Yeah. This is the cardiac potential. This is how you should write in the exam. And phases, you should not just mention the phases. Inside also you should write what is occurring, how it is occurring. Okay. Okay, I think I will start. Let's just finish up with the session. Let's begin. Okay. Cardiac potential. Sorry. Yeah. Cardiac potential. I have already explained in detail, very much in detail, how the basic of distribution of ions is present in our body. How sodium is present more in extracellular, how in potassium is present more intracellular. Little slight difference is there. See, this is our action potential. No? Slowly threshold, shoot, overshoot, and then relaxation. But in cardiac potential, what is happening? Threshold is there, increasing. There is a slight relaxation over here, and then it is staying stable like this, it seems. And then it is relaxing. So what is this funda? I will explain. I will only focus on this funda. Why is this phase coming? What are these two phases that is coming? Here it was completely relaxing after depolarization. Let's see the funda. Okay, let's begin with the stages. We all know the stages. Initially, what will happen? Depolarization. What will happen in depolarization, guys? This is our cardiac cell. Sodium present outside in huge amounts. This is our sodium channels. Initially, what will happen when the stimulus comes from the SA node? What will happen? Tell me. Few sodium channels will open. Few sodium channels will open. Few sodium channels will open. What will that? This is at minus 90 millivolts. Remember, I told you, I explained in detail how it is minus 90. I stressed a lot in this, but now I'm not going to explain all that. Okay, you should know the basics. So normally the cardiac potential now it is at minus 90. Now few sodium channels are opening in the depolarization because of the stimulus from the SA node. What is happening now? Slightly from minus 90 it will go to minus 50. Again, you know this concept. Now I will tell you that this is the threshold. Now since it is a threshold, what will happen when it is threshold? All the sodium channels will activate together. Once the sodium channels get activated together, what will happen? Tell me what will happen? Influx of sodium will occur. Influx of sodium will occur. You already know why there is influx of sodium. What is the reason? Why is there a gradient difference in ionic distribution? Everything is covered. Okay. Now, sodium influx has taken place. Now, what is happening? I'll show you the graphical representation then. Here it is, our graphical representation. Initially, what happened? We were at minus 90 millivolts. What is happening now? Suddenly, it increased to minus 50 millivolts because of few sodium channel activation because of SA node stimulation, depolarization. Now, suddenly, we reach the threshold. This is our threshold. What will happen now? Overshoot. Till here, we know this is all same in our action potential. Now what is happening? Now, there's a trick. What is happening now is few lazy potassium channels are opening. Very few potassium channels are opening. What will happen? Potassium channels efflux out of the cell. Efflux out of the cell. Potassiums are more inside the cell rather than outside the cell. So few potassium channels open slowly. That's why what will happen? What will happen? Already you know minus 90 say it will go to minus 50. From minus 50 it just now went to plus 20. All the sodium channels made the whole cell positive. But since some positive charge is getting lost outside a little bit, very not a huge amount, very less. Suppose I'll tell some 5 MV volts of potassium effluxed outside. So what will happen inside the cell? Negative, it will subtract na, because inside the cell we are measuring. So right now it is at plus 20. Few potassium efflux outside. So minus 5 millivolts. How much? 15 millivolts. This we will express in the plus 50 millivolts. Express in the graph. Let's see in the graph what will happen. Let's see in the graph what will happen. Tell me. A slide like this curve. You see this curve? What is this? Depression. If it is depression, what are we calling it? Repolarization. Already you guys know why it is called repolarization. You guys already know why it is called depolarization. Right? Should I explain again? No. Depolarization means from minus 90, this is normally a polarized state. It is going into a depolarized state. Again, when it comes back to the polarized state, it is called repolarized state. Normally resting stage को polarized state बोलते. Okay, understood this? So yeah, my focus was over here. This thing is happening. Why it's happening? Few efflux of potassium channels are occurring. Now comes the most important phase. Asal, why is this happening? Why this is happening? Okay, let's see. This is our cardiac muscle. Okay, now what will happen is calcium channels are present. Calcium channels are coming in action over here. In action potential, calcium channels are not needed. It is not a muscle to contract. Okay, this is muscle to contract. We need this heart to contract, right? So calcium channels are coming in play. Okay, what will happen? Calcium is more in ECF, not in ICF. Okay, so yeah, so calcium will influx into the cell. Simultaneously with remember this point, potassium channels slowly open हो रहे उसके साथ, with those potassium channels which are slowly opening simultaneously. It is also calcium is influxing also, and you must know that calcium is also a kind of a slow channel. So what is happening in this phase? Tell me. Neutral रहेगा नहीं रहा? Is it remaining neutral? Why is it remaining neutral? Calcium is coming inside, but potassium is going outside. Okay, so positive charge is coming inside also, positive charge is leaving also. What is happening now? It's remaining neutral now. The cell is remaining neutral. So that's why on the graph when you measure this, just after this phase, it's remaining neutral. Now if I ask you, why is it remaining like this? What do we call this phase? We call this phase as plateau phase. Why is it called plateau? Because it's remaining stable, static. Okay. Why is it remaining static? Because calcium is influxing, but potassium is influxing, and potassium is effluxing, but calcium is influxing from outside. So it's becoming neutral. Simple. There's nothing mad science about this. It's easy. Okay. So I will start naming this. So first stage, we will call it as initial. What will you call? You all already know depolarization, right? Next, what should I give the name for this mystery? This mystery over here, which is little bit decreasing like this. I will give this a name known as initial. Initial repolarized हो रहा ना थोड़ा. So repolarization. It is becoming a little bit negative. Then again, there is static phase. It's becoming like this, and this. So this I will call it as plateau phase. Plateau means it's remaining constant. Plateau phase. Why it is plateau phase is occurring? Calcium is influxing, potassium is effluxing, stable rara. This is the most important characteristic phase in the cardiac potential. Cardiac potential mean what is the characteristic feature? Plateau phase is the characteristic feature. Why is the plateau phase occurring? Calcium, potassium, we should tell. Followed by what is happening now? Decreasing now in graph. It will decrease. Finally, last session is known as repolarization stage. Repolarization stage. Okay. I think I have covered very fastly, but yeah, just tell me if there are any doubts, because I had covered in very much detail in action potential session. I didn't go in much detail. Just tell me if there are any doubts.
Fawaz is asking what is the stimulus for calcium channels to open?
Stimulus, sir. There is so see, I'll tell you. I think I got the doubt. This is our cardiac muscle, right? This is our cardiac muscle. SA node, which is present over here, it will send signals. So sodium gets activated, channels get activated, potassium channels get activated slowly, and calcium channels are also coming in action. I already explained how these channels get activated in the last session, like how initially the channels which are present in nearer to the SA node, but actually it was an action potential. But here we are talking about the cardiac muscle, so I'm explaining. Here we had the sodium channels, right? So it will depolarize the initial channel. So influx will occur. Similarly, line say we'll have calcium channels. Okay. There is no separate stimulus, I guess. I think so. There is no separate stimulus for calcium influx to occur.
Yes, these calcium channels are voltage gated calcium channels. So there should be voltage inside the cell for these calcium channels to open, Fawaz. So what is the voltage? The voltage is created due to entry of sodium. So if the sodium is entering, positive charge is increasing. When sufficient positive charge has been attained, the voltage gated calcium channels will open. Okay, that is the stimulus. One more clinical aspect I would like to add now over here is digoxin, your digitalis. Okay, you know about digitalis, right? Digitalis is a positive ionotropic drug. When do we give digitalis? To increase the force of contraction of the heart. To increase the force of contraction. What is the mechanism of action of this digitalis drug? It causes more calcium entry inside the cell. Okay, it causes more calcium entry inside the cell, or else you can say it does not allow calcium to get effluxed out of the cell. That is also acting on your sodium calcium exchanger. Okay, so basically sodium has to be inside for the calcium channels to open, then calcium will enter inside, then it will go to sarcoplasmic reticulum. Over there you will have all those receptors, ryanodine receptors and all. Okay, from that the calcium from sarcoplasmic reticulum, more calcium will now come inside the cytoplasm. Then this calcium will now combine with your troponins and myosin and all. Then contraction coupling will occur. Then your muscle will contract. Hope that clears, Fawaz.
Yeah. Are there any more doubts in this cardiac potential? It's an easy concept. Action potential, it's very much similar to action potential. Just this plateau phase and the initial repolarization phase was the important part. Tell me, are there any doubts in this cardiac potential? Then I will show, yeah, this is how you should
I think there are no doubts in this. How is it getting neutralized when calcium is +2 and potassium is +1? Hello? Sadat, you are not audible. You're not audible. Have you unmuted?
And then repolarization. Hello?
Yeah, you're audible now. Now you're audible.
Yeah. So sorry, plateau phase you have to write like this, and then repolarization like this. So ionic basis you have to write, phases you have to write, you have to draw the graph, definition. Simple. This is a very simple SAQ. Potent SAQ is this. This one is a potent SAQ. Cardiac cycle to definite LAQ. It's a really famous LAQ. So I will send you this pics how to write in the exam. These are the number of pages. You can increase the number of pages. Yeah, that's all I wanted to say. If there is any doubt in cardiac cycle, cardiac potential, kindly put it in the chat box. I think I finished the session in a quite fast amount of time. Yeah, I would like to add another clinical point in this cardiac potential. If you guys are available, if you're ready to hear, just a very small clinical point. See, in cardiac potential, when these ionic basis is occurring, right? So sometimes what happens is
Are
SA
you
node is
writing?
not
It's not visible. It is not visible.
now.
I think you can reshare. Nahi dikh raha. Is it visible, Nusrat? For me, it is not. I mean, the screen is visible, but what you're writing is not being shown.
No, it isn't.
Yeah,
Now?
I think you can stop sharing and then reshare it.
Yeah, I reshared it. I think it's able to be visible now.
No, not yet. नहीं आ रहा अभी. नहीं.
यही क्या हो रहा? One sec, guys. 1 second.
वो बंद करके खोल दे तो आता है.
अच्छा, check once again. Yeah.
No, stop your screen sharing and join back again.
Is it working now, guys?
No, we can't see anything what you're writing.
Achha.
You can do one thing is you can stop your screen sharing right now, and after
Yeah,
after stopping it, yeah.
Achha, I already did that 2-3 times. 1 second. Is it sharing now?
You're talking from your tab, right? But it's showing you're offline here.
Achha, I think there's a
I'll
network
remove
problem.
you as a presenter and then make you a presenter again. Okay?
I think there is a network problem, I guess. Yeah, just try it once again.
Yeah. I think you can just leave and rejoin. Just quickly.
One second.
I'm not getting an option. Or if you can just explain with verbally, I think that should be fine.
Yeah, I think I can explain. I think it's not sharing now also.
Okay.
Share हो रहा नहीं?
नहीं हो रहा.
I think there's a network problem. 1 second. Yeah, okay, I'll just tell verbally. Okay, guys, hear me out. So in cardiac potential, we have these sodium ion channels and calcium ion channels working, right? So what we'll be doing is arrhythmias. Arrhythmias, you must have heard it somewhere. These are disturbances in the cardiac rhythm. Okay, it could be due to abnormality in the origin of the impulse or some problem, right? It is not contracting, or there must be some problem. Just for a touch of clinical aspect in pharmacology, I would like to add that when arrhythmias occur, abnormality in a cardiac rhythm occurs. So that's why pumping of blood does not occur appropriately. So what we should do is we should stop these arrhythmias. So there are certain drugs which we give to block these abnormal rhythms which are being produced through the cardiac potential. For example, if calcium channels are acting to produce these arrhythmias, we have to stop these arrhythmias, right? So we will give calcium channel blockers. What do you mean by calcium channel blockers? These drugs will go and bind to the calcium channel and they will block it, so that depolarization does not occur and the heart does not contract irregularly. Okay, so it does not stop contraction of the heart. Okay, it acts on a few amount of channels so that it reduces the arrhythmias. So such as, write it down if you want to write it down, calcium channel blockers such as verapamil, VERAPAMIL. Okay, verapamil. This is one calcium channel blocker. Also, we can give sodium channel blockers also, such as quinidine. Quinidine. Write it down. Quinidine. Quinidine. Okay. That's all I wanted to add. Okay. If there are any doubts, just let me know, guys. And please fill in the Google forms. It would be of great help.